Hello students, we'll start with Unit 4, Theory of Sets, Permutation, Combination and Matrix. We'll start with matrix. A rectangular arrangement of symbols or numbers in a rows and columns is called matrix. The symbols or numbers in a matrix are called as elements of matrix. Matrix can be denoted by any letter A, B, C, D, X, Y, Z. Okay, so suppose X is equal to 1, 2, 4, 7, 8, 3. Okay, so this is a matrix represented by letter A, and 1, 2, 4, 7, 8, 3 are the elements of matrix. Now this matrix has two rows, row number 1, row number 2, right, and 3 columns, 1, 2, 3. Correct? So this is 2 into 3 matrix. So 2 into 3 is order of the matrix. Okay. Similarly, y is equal to 4, 5, 7, 8, 7, 2, 8, 5. Now this matrix is denoted by y. This has 3 rows and 2 columns. So the order of the matrix is 3 into 2. So first one is row and second one is column. Okay, so this is called order of matrix. Similarly, another example, A is equal to 1, 4, 2, minus 1, 3, 2, 4, 0. Now this matrix A has 2 rows and 4 columns. So order of matrix A is 2 into 4. Alright. Okay. So now this matrix, these are the elements in the matrix A. The elements are 1, 2, 3, 4, 4, minus 1, 2 and 0, right? So how do you represent the elements of the matrix? So this one, first one, which is in row 1 and column 1, it will be represented by A11 because it is row 1 and column 1. So A11, this is equal to 1, right? A12, which is row 1 column 2. So A12 is 2, right? A13 means row 1 column 3. Row 1 column 3 is 3. So element A13 is 3. A14 is 4 because A14 means row 1 column 4. So row 1 column 4 is 4, right? Similarly, A21 means row 2 column 1. So row 2 column 1 is 4. A2 column 2 A22 is minus 1. A23 is 2 and A24 is 0, right? So this is how elements of the column is represented. Okay, the first number is row, second number is column. Okay, now let's come to types of matrix. So I can say that a matrix A is equal to A, I, J, M into N, where M is row, number of rows, N is number of columns. So Mn is order of the matrix. Aij is elements of matrix. Okay. So here one is I and this one is J. This one is I, this one is J. Okay, and this Mn here is 2 into 4. Okay, this is how it is represented. So let's come to types of matrix. We will do these kind of sums later and it will be clear. Now types of matrix. First type is row matrix. Row matrix has one row and it can have many columns. So order of the row matrix is 1 into n. For example, A is equal to 1, 2, 7, 8, 9. So this is a row matrix because it has only one row and it has 1, 2, 3, 4, 5 column. Right? Number of column, a row matrix might have n number of columns but only one row. So that is called as row matrix. Second one is column matrix. Column matrix has one column. For example, B is equal to 1, 3, 4. Okay, so this matrix has 3 rows and one column, right? So column matrix, it can have n number of row but only one column. That is called as column matrix. Row matrix has one row and it can have many columns. Okay, next one is square matrix. Square matrix has equal number of rows and columns. If there are 2 rows, then it will have 2 columns also. And if it has 3 rows and 3 columns, then it is called as square matrix. 4 rows and 4 columns, then it is called square matrix. For example, M is equal to 1, 3, 5, 6. Now this has 2 rows and 2 columns. So this is 2 into 2, right? So this is a square matrix. N is equal to 5, 6, minus 1, 3, 2, 7, minus 8, 9, 3. So this is a square matrix because it has 3 rows and 3 columns. Okay. So if M and N are equal, that means order is number of rows are equal to number of columns. It's called as square matrix. Next one is diagonal matrix. Now diagonal matrix, from the name itself, so it should be a square matrix. Number 1, first property, it has to be a square matrix. Suppose 1, 2, 0, 0. But only this diagonal has an element. Other elements are 0. Then it is called as diagonal matrix. I'll give you another example. For example, 5, 0, 0, 0, 3, 0, 0, 0, 6. Okay. So diagonal matrix is a square matrix in which all elements are 0 except the principal diagonal. This is a principal diagonal. Okay. So that is a diagonal matrix. Next one is scalar matrix. What is scalar matrix? If the diagonal matrix, if it is a diagonal matrix and the principal diagonal elements are equal, it is called scalar matrix. For example, x is equal to 4, 0, 0, 4. So this is a diagonal matrix, but the elements of the diagonal are same. So that is called as scalar matrix. Right? So this is a diagonal matrix. All elements are 0 except the principal diagonal, and the elements of the principal diagonal are same. It is called as scalar matrix. Next one is unit matrix. Unit matrix is also called as identity matrix. So that's why it is represented, it is denoted by I. So unit matrix or identity matrix. So identity matrix is denoted by I, okay, and it looks like this 1 0 0 1. So this is also a diagonal matrix, but the principal diagonal has 1, okay, and because it is 2 into 2, it can be represented as I2, okay. So I3 will be 1 0 0 0 1 0 0 0 1. So this is also a square matrix, principal diagonal, and it is a diagonal matrix, but and all the elements of the diagonal is 1. So this is called as identity matrix, okay, or a unit matrix. Next one is null matrix. Null matrix, when all the elements are 0, it is called as null matrix. It is also called as zero matrix. Null matrix or zero matrix. So zero matrix is denoted by letter O, okay, and all the elements are 0. Okay, O, so if all the elements of a matrix is equal to 0, such matrix is called null matrix or zero matrix. Next one is upper triangular matrix. Upper triangular matrix. Now in this, it is a square matrix, is called a upper triangular matrix if all the elements below the principal diagonal are 0. So if A is equal to 1 2 5 0 6 3 0 0 1. So if all the elements below the principal diagonal, this is a principal diagonal, if all the elements below the principal diagonal is 0, it is called as upper triangular matrix. Another example, 2 0 minus 1 3. Okay, so this is also a upper triangular matrix. So below the principal diagonal, the element is 0. All the element is 0. Similarly, next one is lower triangular matrix. Now here it is a square matrix. If all the elements above the principal diagonal are 0, it is called as lower triangular matrix. So ninth one is lower triangular matrix. So X is equal to okay, 3 into 3, sorry. So all the elements above the principal diagonal is 0. So that's why it is called as lower triangular matrix. Okay. Another example, y is equal to 8 9 10 0. So here also above the principal diagonal the element is 0. So this will be called as lower triangular matrix. Okay. Next one, next topic is transpose. And we have finished types of matrix. Now transpose of matrix. So what is transpose of matrix? When suppose matrix A is 1, 2, minus 1, 3, 6, 0. This is 2 into 3 matrix, correct? So transpose of matrix A will be when rows becomes column. Okay. So transpose of A will be represented by A dash. Okay. So here row 1 is 1, 2 and minus 1, right? Now if my column becomes 1, 2 and minus 1 and row 360, row 2 is 360, so my column becomes 360. Okay. So this will be called as transpose of matrix. Okay. When row become column and column becomes row. See here, column is 1 and 3 now. Row is my 1 and 3. Column here is 2 and 6. Here it is, row is my 2 and 6. And here column is minus 1 and 0. So, and here row is minus 1 and 0. Correct? So, when rows becomes column and column becomes rows, that is called as transpose of matrix. So here in transpose of matrix, if order is 2 into 3, the transpose will become 3 into 2. Okay. So this can be denoted by A dash, or it can also be denoted as A raised to T. Okay. So similarly, if my B is 5, 6, minus 1, 7, this is 2 into 2 matrix. Correct? So my transpose of matrix will be B dash, or B raised to T will be, my rows will become column and column will become row, right? So 5, 6, minus 1, 7. So if this is a matrix B, the transpose of matrix B will be this. Okay. The next one is symmetric matrix. Let's do that topic also today. Symmetric matrix. What is symmetric matrix? Symmetric matrix, if the upper triangle and lower triangle are equal, it is called a symmetric matrix. For example, if my symmetric matrix is if my transpose and my matrix and the transpose of matrix are same, it is called a symmetric matrix. For example, A is equal to 5, 1, 0, 2, 4, 6, and here also 2, 4, 6. So this is my A, right? My A dash, my transpose of matrix will be, my rows will become column, right? So this is 5, 2, 4. So 5, 2, 4. 2, 1, 6. 2, 1, 6. 4, 6, 0. So 4, 6, 0. So if I see A and A dash, both are same. Correct? So if a matrix and its transpose are same, it is called as symmetric matrix. So A is equal to A dash. Okay. So it is called as symmetric matrix. Okay. So in case of symmetric matrix, what happens? See, you take this diagonal and you just see the elements above the diagonal and below the diagonal. It's same. Okay, so that is called as symmetric matrix. Wait, I'll show you again. Wait. Now see here. Okay, now you just ignore the diagonal. Okay, now let's see the elements other than the diagonal. So this is 2, this is 2, this is 4, this is 4, this is 6, this is 6. When the elements are arranged this way, it will be a symmetric matrix, because then A will be equal to A dash. Okay, in case of transpose of matrix, the diagonals never change. See, diagonal here is 5 1 0, here also 5 1 0. See here, B was the diagonal is 5 7, B dash also 5 7, right? Only in case of square matrix there will be a principal diagonal. Okay, in case of rectangular matrix, there is no diagonal, there is no principal diagonal. Okay, so next one is skew symmetric matrix. What is skew symmetric matrix? When A dash is equal to minus A, it is called as skew symmetric matrix. For example, my A is 0, 2, minus 2 and 0. Okay, so that means my minus A will be, instead of writing 0, I'll write some number, that would be better. No, in skew symmetric matrix, diagonals are always 0. Okay, so in skew symmetric matrix, the diagonal is 0. Okay, and if the element opposite, okay, are just the negative number, it is called as skew symmetric matrix. Okay, so this is 2, this is minus 2. So how my minus A would be? My minus A is 0, 0, 2 will become minus 2, minus 2 will become 2, and 0 will remain 0, right? So this is minus, this is A, this is minus A. What is A dash? A dash is transpose of A. The rows becomes column, right? So it is 0 2, my row is 0 2. So here my column would be 0 2, minus 2 and 0 2, minus 2 and 0. So minus 2 and 0. Okay, so here minus A and A dash is same, right? So this is skew symmetric matrix. So this is skew symmetric matrix. Okay, I'll give you another example. B is equal to, so a square matrix A is called skew symmetric matrix if A dash is equal to minus A, okay, or B dash is equal to minus B. In skew symmetric matrix, all the diagonals elements are 0. All the elements of the diagonals are 0. For example, B is equal to, I'll just write the diagonals first, then minus 3, 4, and suppose this is 2, minus 2, 4, and sorry, wrong. This is minus 2 and this will be 3. This is 4, so this will be minus 4. Yeah. Now this is a matrix. Elements are 0, minus 3, 4, 3, 0, 2, minus 4, 2, minus 2 and 0, right? So this is matrix B. Okay. So my minus b will be, the diagonal is going to be 0, 0, 0 only. Minus 3. So minus 3 will become 3. 4 will become minus 4. 2 will become minus 2. 3 will become minus 3. Minus 4 will become 4. And minus 2 will become 2. So negative becomes positive, positive becomes negative. And diagonals remains the same, which is 0. So this is minus b. Okay. If b is this, so minus b will be this. Okay. So let's see transpose of b. Transpose of b is, that is b dash will be, my rows becomes column. So this is a column which is 0, 3, minus 4. I'll write that becomes my first row. My first column becomes first row. So 0, 3, minus 4. Next one is minus 3, 0, minus 2. Minus 3, 0, minus 2. And 4, 2, 0. 4, 2, 0. So if you see, minus b is equal to b dash. Okay. So this is skew symmetric matrix. Okay. Next one, last one, which is equal matrix. When two matrices are exactly same, it is called as equal matrix. When two matrices are exactly same, for example, A is equal to 2, 3, 0, minus 1, 6, 2. Okay, and B is also equal to 2, 3, 0, minus 1, 6, 2. So they are equal matrix. Okay, if in the question, if it is given x, y, 2, 3 is equal to 1, 5, A, B. That means they are equal matrix. So here x is equal to 1, y will be equal to 5, A will be equal to 2 and B will be equal to 3 because they are equal matrix. Okay. That's it for today, students. Have a great day. Thank you very much. We'll be solving problems from the next class.